Hello there, Mr. Wilson here again for what is another video in looking at the binomial theorem, specifically targeted for GCSE Further Maths students. And in this part, we're going to look at what happens when in the brackets you have a different number other than 1. Because in the previous part, if I go back a page, we looked at this idea of how Pascal's triangle can help us write out any expansion where it is x plus 1. So, for example, x plus 1 to the power 6, the numbers in Pascal's triangle tell us the coefficients of the terms in the expansion. And we just look at the appropriate row to tell us what the expansion will be. And we ended on this moment where we came to the realization that, for example, x plus 2 squared is x squared plus 4x plus 4, which isn't the 1, 2, 1 that we would expect from the second row of Pascal's triangle. So what we're going to look at in this video is what happens when it isn't 1. Well, we can still use Pascal's triangle, we just have to think about it in a different way. We have to approach it in a different method. So let's have a little look then. If you haven't done so already, I would highly recommend looking at the other videos, unless you are confident with what was explored in them, because we're sort of just going to go from that moment. So just as a reminder then, x plus 1 squared is equal to x squared plus 2x plus 1. And the second row of Pascal's triangle is 1, 2, 1, which makes loads of sense. However, the expansion of x plus 2 squared is actually x squared plus 4x plus 4, which isn't the 1, 2, 1 we would expect from the second row of Pascal's triangle. However, we can still get this value just in a different way. So, when you perform the binomial expansion, or you perform any expansion for that matter, you're always going to have if you expand in two brackets, of course. So let's say I wanted to know what x plus 3 squared is, but I'm going to use the binomial theorem for this. Now, obviously a lot of you will be watching this and thinking, oh, I know the answer to that. I'm just using a simple example just to illustrate my point, and we'll look at some more complicated examples in a little bit. So the basic idea is, when you expand this, I know I'm going to get an x squared term, I'm going to get an x term, and then I'm going to have a term with no x in it. It's just a number. Because I know that when I expand this, that's what's going to happen. I'm going to get descending powers of x. And that happens when you expand x plus 1 squared and x plus 2 squared. Now, the other term does the same thing, but the other way. And this is the binomial part of the binomial theorem. So if I'm going to have an x squared term here, an x term, then no x, well, starting from this right-hand side, I'm going to have a 3 squared term, a 3 to the power 1, or 3, and then no 3 there. Now I can work this out. I would get x squared, I would get plus 3x plus 9. Now, that isn't the correct expansion, right? That isn't the correct answer. The correct answer is x squared plus 6x plus 9. So how am I going to get that answer? Well, if we remind ourselves about that second row of Pascal's triangle, the second row of Pascal's triangle is 1, 2, 1. So if I multiply each of these terms by the number in Pascal's triangle, I will get the answer that I'm looking for, which is x squared plus 6x plus 9, which is the correct answer. So that is the binomial theorem. So the key idea here, and it's a very weird idea to get your head around at first, when you are expanding, and this is the fundamental idea of the binomial theorem, when you expand, you have your first term, in this case is x, it could be any letter or any number, but the first term here, x, is in descending powers, so we have x squared, x, no x. Whereas the other term, in this case the 3, is the kind of the opposite way. It has no 3 here, then a 3, then 3 squared. Let me show you with a triple bracket just to illustrate this point. So let's say I wanted to expand x plus 2 cubed. Now I'm sure that you could expand that triple brackets, that's absolutely totally fine, but I just want to illustrate the point through the binomial theorem. So when I expand this, I know I'm going to get an x cubed term. I know I'm going to get an x squared term. I know I'm going to get an x term. And then I know I'm going to have a term with no x in it. Now the other term is the 2. Now the 2 is doing the same thing as what the x's are doing, but in reverse. The powers are going the other way. So this term here is going to be a 2 cubed. This is going to be a 2 squared. This is a 2, or 2 to the power 1. And this is no 2. And I can work these out. So I'm going to get x cubed plus 2x squared plus 4, because 2 squared is 4, 4x plus 8. Now that's not the correct answer, because the step that all students forget is to multiply by the value in Pascal's triangle. That is essential. Pascal's triangle is integral to the idea of the binomial theorem. So we would multiply each of these terms by the row in Pascal's triangle. Now, we're expanding to the power of 3, so we're going to use the third row in Pascal's triangle, which is 1, 3, 3, 1, and you can check that on your Pascal's triangle. So we need to multiply each of these terms by the correct value in Pascal's triangle. So that's just going to make this still x cubed. That's going to make this 6x squared. That's going to make this 12x. And this one is going to be that plus 8. And that's the correct expansion. If you actually expand that, triple brackets, you will get that. That is the correct answer. So the binomial theorem is a fantastic way, once perfected, of expanding brackets without having to take ages. And it still works even when the number is greater than 1. Okay, let me do an example which would be a typical GCSE Further Maths style question. They would use a larger power than 3 usually. So let's do x plus 2 to the power 5. Well, I know when I do this expansion, I'm going to have an x to the power 5 term, an x to the power 4 term, an x cubed term, an x squared term, an x, and then no x. Now, some students like to draw lines like this and then write the things on the line. That is totally fine. It's however you want to set it out. And I said to my students that about 90% of the binomial theorem is just setting it out. Because realistically, all you are doing is just evaluating powers and multiplying, which is not tricky because usually it's a calculator question. So that's not overly tricky. So the idea that the main idea behind the binomial theorem is just that you need to set it out right. Set out is most of this question. If you can lay your work out correctly, then the answer just basically falls out. So once I've got my descending powers of x, I can then do the other term, which in this case is 2, and I can do it in reverse. So I've got, I'm going to have a 2 to the power 5 term here, 2 to the power 4, 2 cubed, 2 squared, 2, and then no 2. And then I'm going to work these out. So I'm going to get x to the power 5 plus 2x to the power 4 plus 4x to the power 3 plus 8x to the power 2 plus 16x plus 32. And again, that's not the correct answer because we need to multiply by the row in Pascal's triangle. Now the fifth row, because it's the fifth power, is 1, 5, 10, 10, 5, 1. So I need to multiply this one by 1, this one by 5, this one by 10, this one by 10, this one by 5, and this one by 1. So the correct final answer has got to be x to the power 5 plus 10x to the power 4 plus 40x cubed plus 80x squared plus 80x plus 32. And that will give me my final answer there. So this pattern will sort of always work for this idea. We've got x plus something. Now, whatever number that might be, now obviously if you have a power of 5 and then the thing in the brackets is 7, you're going to get some really large numbers here, but the process is the same, right? You're just going to get some large numbers because you're going to have to be doing sort of 7 to the power 5, 7 to the power 4, which is going to give you a large value, and then you're going to have to multiply it by something else. So don't be afraid of getting large values for the binomial theorem. That tends to be a common theme among a lot of questions. Okay, I'm going to leave it there for this part. Hopefully that sort of clarified this. So in this part we looked at what happens when it's a number other than 1. So I'm talking a number greater than 1 in the brackets. In the next parts, well, in the future parts, we're going to look at what happens if it's something like 2x plus 1 to the power 3. Or what happens if it's x minus 4 to the power 3. Or what happens if it's 3x minus 1 to the power 5? We're going to have a look at all those examples. Nice ones where they've got a value in front of the x, ones where they've got a negative in there, lots of different ones. And we're going to have a look at how that has an effect on the expanding. How do we need to sort of tweak, not necessarily change, but be careful of these things when we are doing the binomial theorem, because obviously there's going to be a slight difference between doing x plus 4 to the power 3 and x minus 4 to the power 3, but we need to understand the slight differences there, and that is going to be in a future video. So hopefully if you enjoyed this video, definitely check out all the other videos on the channel, subscribe if you haven't done so already, and all I want to say is thank you so much for watching, and I hope you have a fantastic day.